We've got an 85 kilogram pilot traveling at 72 meters per second in a jet or an airplane, and he's going to like swoop up, and the pathway is going to have a 320 meter radius. Now, obviously, when a pilot in a plane comes down and scoops around, they feel a lot of pressure on their body. And we're going to look at it right at the very, very bottom, and we're going to find out at the very, very bottom of the pathway here, we're going to find out how much force is acting on him, and that would actually be the normal force that's acting on his body. And we're also going to find out how many G's there are. And G's is just an acceleration calculation used to compare to the acceleration due to gravity. It's relatively common. You can compare any kind of acceleration you want, but it's often done with circular type stuff when pilots are doing crazy maneuvers in their jets and planes and stuff like that. Okay, well, let's just start with the basic forces type stuff and see what's going on with that. I know there's a couple forces acting on him. I'm going to start with the simplest force possible, force of gravity. We've got the force of gravity of the pilot is just going to be mg, and that's pretty simple to calculate. That's just going to be around 834 newtons. Obviously, circular motion is involved, so I'm going to calculate my Fc. So I can calculate my mv squared over r. I've got his mass, I've got his speed, I've got the radius. If I put those together, we are looking at around 1400 newtons for that. So when he's at the bottom of the path down here, there's two forces acting on him. You've got the force of gravity pulling him down, and if he was just sitting there at rest doing absolutely nothing, the Fn would just be equal to the mg because he's sitting there at rest. But he's not just sitting there at rest. Not only does he have force on his butt from bouncing off gravity, but he's got extra force because he also wants to go in circular motion. So we are going to take those two forces and we are going to add them together, and you got a total Fn of about 20, we'll say around 2200 newtons. So about 834 of that was for gravity, and about 1400 of that was to balance off Fc. So you put those together, you got an Fn around 2200 newtons acting on his body. Now, what about the G's? Well, the G's is just acceleration. That's all it is. So there's a couple you can do the force all together if you want, or you can do them separately. It doesn't make any difference. If I would take just the Fc right there, if I do the Fc divided by mass and calculate the centripetal acceleration, just basically Newton's second law, just to do that 1400 newtons, the centripetal acceleration, give or take about, is going to be around 16.5 meters per second squared. Okay, now if I would just convert this into G's, all I have to do is divide by 9.81, and this is, give or take, this is about 1.7 G's. So he's experiencing 1.7 G's just to swoop and do the circular motion component. But there's also the force of gravity that he has to balance out. So the chair or his seat is also pushing up with 1 G just to cancel out the force of gravity. So I'm going to add another G for that, and altogether you're looking around 2.7 G's altogether. You could have also done this just by going directly to the total force acting on him. If you do that 2200 and you divide by his mass, you'll also get around 2.7 G. So it doesn't really make any difference how you actually go about doing it. And you can find his acceleration, the total acceleration acting on his body, divide by 9.81, and then you can compare that in terms of G's.